Welcome back to this lecture series of atomic packing factor. So this is the case studies of third. So in this lecture, we'll be discussing on the packing factor for face-centered cubic structure. We'll be find out the atoms per unit cell, coordination number, atomic radius, and then we'll be compare the simple cubic structure, body centered cubic structure, and face centered cubic structure, the analyze. So let us move forward. That for FCC structure is basically in the face centered cubic structure is a non-primitive cell. It consists of 6 atoms centered on each 6 face and the 8 atoms at 8 corners. So for considering this, that first point is it is a non-primitive cell and it consists of 6 atoms centered on the 6 faces and 8 atoms at the 8 corners. We shall now determine the characteristics of face-centered cubic structure. So first, as we mentioned in earlier lecture for case analysis or body-centered and simple cubic structure, that will be considered here all are in we shall consider the hard sphere model, and this left side, this left panel image is this is the atomic site model, and this is the alternating atomic layers for this FCC structure. So first we will be find out the number of atoms per unit cell. Number of atoms per unit cell. So there are 8 atoms, each shared by 8 unit cell at 8 corners. So if we write it that there are there are 8 atoms, each shared by 8 unit cell, and they are at 8 corners, and along with this there will be the 6 face-centered atoms, each shared by 2 unit cell. Two cell. So therefore the total number of atoms per unit cell that will be equal to contribution due to this is 8 atom. So that is basically 1 by 8 into 8 plus this 6 face centered and each shared by 2 unit cell. So 2 unit cell means half into 6. So this equal to that is 4. So total number of atoms per unit cell that is equal to 4. So now we shall find out the atomic radius. So will be to find out the atomic radius. So let us first consider that that atoms are connect along phase diagram. So let us consider a diagram. And then let us consider a and so this will be also connecting the corner way. It should touch. And same thing here, this side also you can find out. Okay, so let us consider this structure as A, B, and this corner we can just say as F, and this is E. So from here to here, this is basically this will be R, and this is R, and this entire part will be 2R here to here, and this sides is A. So for FCC structure, we can write as that length of this phase diagonal, that is AF, is basically 4R, and then we can write as AF square is equal to AB square plus BF square. So we define as that. So this here actually one atom is there. So this will be 4R square is equal to A square plus each side is the A. So this is equal to twice A square. So then we can find out R is equal to A divided by 2 root 2. So this is the atomic radius for case of the for FCC structure. Now we shall find out what is the coordination number of this structure. So now we'll be finding out. So now we'll be finding out the coordination number. So coordination number, we know that the nearest neighbors of each corners are the phase shunted atoms. So of the surrounding unit cell. So any corner atom that has the four such atoms in one place. So 4 in above it and 4 in the plane below it. So the coordination number will be total. So total coordination number will be that will be 12. So now we will find out the packing factor of now we will be finding out the packing factor for this FCC structure. That if we find out the packing factor, so packing factor, that is let's say here the that equal to small v divided by capital V. So here small v in is 4 into 4 by 3 pi r cube, because here 4 is the number of atoms uh, per unit cell, and this capital V, that is the volume of the unit cell, is a cube. So we can find it. If we just simplify this one, we can find out pi divided by 3 root 2. Since we know the lattice parameter A is equal to 2 root 2 r. So if so, then we can find out this is equal to 0.74. So the packing factor is 74%. So when we compare with the SC and BCC, this is the highest packing factor. So most of the metals like copper, aluminium, lead, silver are these under this FCC structure. So now let us compile the whole unit cell structure with this other kind of structure, like a simple structure BCC, FCC, HCP, and a structure. The number of atoms per unit cell, while is we can say that going to that would be its complex structure, starting from 1, 2, 4, 6, and 8. Atomic radius also you can see that increases. So let us look on that's discussed in this lectures, the packing factor parameters. You can see for simple structure it is 0.52, BCC with increase 0.68, FCC 0.74, HCP also 0.74, and then for DC structure it is 0.34. So for simple structure example is polonium, for BCC iron, barium, chromium, for FCC structure aluminium, copper, lead, gold, HCP structure magnesium, zinc, cadmium, DC structure germanium, silicon, carbon, diamond, etc. So hope this lecture will help you very fundamentals to find out the characteristics of the simple cubic structure BCC, FCC, and to compare their number of atoms, atomic radius, nearest neighbor distance, coordination number, and the packing factor, and have an idea on basics on their packing factors and their arrangement of the atoms with the examples. Thank you very much for watching the video lecture, and please like and subscribe my channel. Thank you.